I'm just wanted to talk to you today a little bit about BALFZ and the testing involved in BALFZ. A lot of you may not have seen what's involved in the testing. Also compare that to some of the other methods like 1530.4. So, and also talk about condensation management as well with BALFZ roofs. So, slide. It's got a clicker. Oh, just wrong green button. So, as far as the test for BALFZ, it's 1530.8.2. So you may have heard about that test method in talks about DCS provisions, for example. And what that test involves bolting the specimen of interest to a furnace, and that furnace operates according to a pre-programmed temperature ramp. And it's quite a precise ramp. And in that test, the exposure goes for 30 minutes and then it stops. Sorry, for 1530.4. And so once that exposure is done, the specimen comes off, and that's the end of the test. There's measurements of the temperature on the unexposed side, as well as observations of whether there was any gaps opening up or any flames coming through. So that's the standard fire endurance test. Typically for zero-lot boundary walls, for example, where you might need 60-60, or for even for FZ, where you can use 1530.4, where you're more than 10 metres from the classified vegetation. So that's the test there. You can see there at 30 minutes, the temperature's getting up to 842 degrees. And this is just an image showing what the test looks like in a horizontal situation, a floor slab, and you can see that it's very very hot. Things are glowing red. So you can see that everything. By contrast, 1530.8.2, whilst it has the same exposure, there's further components. So after the 30 minutes exposure on the furnace, there's a dwell time. So the specimen is taken off the furnace and further observations are made. So there's still the same temperature exposure, but there is further criteria to examine after it's been exposed. So it's still got that 30 minutes. And there's, for example, after it's taken off the furnace, there'll be continuing monitoring of temperatures inside the specimen to examine what's happening and how effective the barrier has been. But also there'll be a radiometer measuring any heat flux that's coming from the specimen after the furnace. So any continued burning and flaming, for example, are examined in this process. So you've got 30 minutes after the furnace for things to settle down, and then another 30 minutes of measuring, and that's where the criteria of if there's still flaming, for example, that becomes the criteria whether you get the FZ or not. Here's some examples of different tests. So the one on the left shows an example where it hasn't gone so well. So we're testing all the time. We've done at least 6 roof tests over the years, and we know now what's involved in getting a good result. And you can see there that on the thermocouple chart, that in this particular case, after about 80 minutes, something reignited, because compared to the furnace, you've got more oxygen available after it's come off the furnace, and so things that are smouldering can reignite. Whereas on the right-hand side, we've got an example where there's everything's gone well. The barrier has been effective. There's been a prevention of conduction and convection of heat from the furnace into the interior. So AS 1530.8.2 is significantly more severe, for example, than say 1530.8.1 BAL 40. You see the sort of damage that the furnace does to the element, particularly steel and any combustible materials. So the 1530.8.1, you have the element or the specimen at a distance from the furnace, quite a significant distance. So it's only being radiated, in effect, by the kilowatts of interest. Interestingly, though, if you're going for a BAL 40 and you're doing a test with a 40 kilowatts exposure and you don't pass, that doesn't mean that you can somehow get down and say, well, it might be okay for 29. So you've got to pick that BAL fairly precisely, because otherwise it means a repeat test or a different construction method. So that's great. With a BAL FZ roof, it's all tightly enclosed, and we need that because we've got to keep all of the gases from the furnace out and all the radiant heat. But it was obvious from last year that there were some concerns, particularly around moisture management and condensation, and Mark Davis gave a talk about that last year, and so we took that on board and listened to that. In the NCC, in the housing provisions, particularly in climate zones 6, 7 and 8, the requirements, the DTS provisions require that the roof space, I'll cut down to the bottom there, that effectively you have to have ventilation in most cases to achieve that moisture management and condensation management. But the issue is that having ventilation means that you're not going to achieve an FZ rating in any way, because if you're exchanging gases with the environment during ambient temperatures, you're going to exchange gases and heat in a bushfire. So there is a concession or an exemption, and in effect, the NCC says, well, sorry, we can't help you. The FZ trumps condensation management, so don't worry about ventilation. So this is just a snapshot from the NCC showing the sorts of openings and the surface, the area that's needed. So as I said, the DTS provisions assume that you can't have those two together; they're mutually exclusive. But ventilation is far more effective and measurable than relying on vapour permeability of the envelope. And as we're moving to having greater energy efficiency as well, ventilation of the roof is even more important because it has the ability to remove excess heat in the roof space. So ventilated roof space. Vents that allow gas exchange will also allow gases from a bushfire event into the roof space. Can a ventilated roof space survive BAL FZ or for that matter, the AS 1530.8.2 exposure? And the answer is yes now, because we have a ventilated BAL FZ roof system, and it's tested at 1530.8.2. So we've always had the plus 60, the Firefly, a blanket system for the roof system, but now we've got a whole range of services that pass through that solves some of the issues in the past with these sorts of penetrations. So just to touch on the plus 60 system again, the blanket itself has an R value of 0.31 compared to board systems where you might only get as good as 0.06 R value. So you're getting some increased energy efficiency through that. It also provides a thermal break between conductive materials. It's a water barrier as well. It's lightweight, so at 2.2 kilograms per metre squared compared to the Appendix H with boards and other systems that rely on boards. It's far lighter and easier to manage on site. It's non-combustible, and it's also tested in roofs and walls. So the great thing now is with a ventilated roof. So we've done testing by incorporating intumescent dampers into the roof system, and it also relies on using our Firefly bats for installing those dampers in, and so the whole system enables both ventilation and protection from fire. I won't go into too much detail here, but certainly come out and see us at the stand, and I can explain all the different components. But in effect, we're getting openings there that provide gas exchange during ambient conditions, but they close off during a fire. So you can see there, that's an image of the installation. The vents there are open in that case, but after the test, you can see how everything is closed off the intumescent material has expanded due to the heat and closed that off. And if we look at the graph, so this was some extra measurements we took. You can always look at extra data, but if you don't have the measuring there, you don't know what's happening. So we included thermocouples to measure the gas coming through the damper. And we can see that, yes, it rockets up for a very short time. It's not part of the FZ criteria in this case. It's more for trying to understand what's happening. But you can see how effective they are at closing down, because within minutes, it's swollen, it's expanded and shut those vents off to any gas flow. In addition, we've also done other work, so still kind of on the from the perspective of ventilation, we've tested sewer vents, so steel pipes passing through the plus 60 blanket, further protected on the underside of that blanket with our Firefly bat and mastic sealant. I just want to point out that though in these, we've had some questions about these boots. These are just purely the orange material there. They're for weatherproofing. They don't actually contribute to the fire resistance in any way. In the test, they burn off fairly quickly, and we're relying on those other components within the aperture that we've included there. They're the primary product and materials that give the fire resistance and prevent passage of fire. Again, we've got a flue, so AS2918 compliant flue system tested, and we have that available too. So you can have your slow combustion stove in a BAL FZ roof, passing through a roof. Again, just in relation to the boot, there are other weatherproofing materials you can use other than that boot, but that was what was tested as far as the combustible material is concerned. And that's it, I'm over. Just to mention that Firefly, we're part of the Fothergill Group, which is a UK-based company, and our companies date back to 1847, so we've been around for a while in the manufacture of high performance fabrics and fire protection materials. So that was all.